Ever wonder how AI learns to think like us? Well, in this video, we're going to dive into two key ways that models are able to improve their reasoning capabilities. First, we'll talk about different training techniques and how these techniques can be used to improve the model's innate reasoning ability. And then next, we'll talk about inference time optimizations and how these optimizations can be used to allow the model to explore multiple different solution paths before deciding on a final answer. I'm Tula Masterman, a principal data scientist, and today we're going to be diving into AI reasoning. But before we get started, let's briefly review how language models are built. First, these models are trained on a large variety of data, and this helps models to understand general patterns in language. This foundational step allows the model to perform next token prediction. So if I have a sentence like, "the cat sat on the fill in the blank," the model learns that the next most likely word or token is mat. So now I have the sentence, "the cat sat on the mat." And while this next token prediction is important, and it's great that the model has a general understanding of language patterns, typically these models need to undergo other sorts of training steps to make them more usable. This is where we get into things like fine-tuning and preference alignment. So most models, like a GPT-4o or an o1, or models from Meta, like their Llama 3.2 series, are going to need to undergo these additional training steps, which are optimizing them for different types of chat-based interactions or instruction-following situations. Most of the initial models that people were interacting with, like a GPT-4o, are great at things like System 1 type of reasoning, or this really fast and automatic type of responses, but they weren't as great at things like System 2 reasoning, which requires much more deliberate and conscious thought in order to come up with the final response. The push towards reasoning models is more about how do we get AI to engage in System 2-like behaviors, where the model is showing more deliberate reasoning over time, and this is what's leading to models like OpenAI's o1 and o3 series, and what's also leading to other models like DeepSeek's R1, which we previously covered in one of our more recent videos. So how do we promote this deeper System 2-like reasoning? Well, one approach is through additional training steps. So the pre-training is what's allowing the model to learn the base understanding of language, and then post-training involves other training steps for additional modifications to the model that teach it more particular types of behaviors. So for example, the post-training pipelines in many models often include steps for both supervised fine-tuning and reinforcement learning. Supervised fine-tuning requires you to have some sort of labeled data set. This could be for a simple task like summarizing in a certain tone, where you would give examples of much longer form content that you want to be summarized, and then a sample for how you want this information to be summarized. How this translates to something like reasoning is you'd give a model a task description, and then you would give it a labeled example of how it should actually break down that task into more appropriate reasoning steps. Supervised fine-tuning is often done in conjunction with reinforcement learning, which rewards the model for engaging in particular types of behaviors and allows it to learn through trial and error. Recent breakthroughs like DeepSeek's R1 actually used a multi-stage training pipeline where they alternated between supervised fine-tuning and reinforcement learning training steps. So once these post-training steps are completed, you end up with a model that users can actually interact with, and this model will have learned the behaviors that you've trained and incentivized through both the SFT and RL processes. As an alternative to model training, you can also focus exclusively on updating the model's ability to perform during inference time. So by providing additional computing power at inference time, you can actually give the model the opportunity to explore many different solutions and identify which solution is the best solution for a particular problem before generating a final response. There's quite a few different techniques that can be used when it comes to inference time or test time compute scaling, and we're going to dive into a few of them in this video. Some of the popular strategies for inference time compute scaling include both self-refinement, and in this case, the model is working on a problem, it creates an output, and it iteratively refines that output until it gets to a final solution. Another alternative is actually the search against a verifier strategy. And there's a couple of great resources that we'll link that go into this in more detail. Some of the common search against a verifier techniques include best of n. In this case, numerous responses are created, and then a verifier just scores what the best response is, and then that response is returned to the user. Another technique is beam search, which actually builds off of the best of n scenario. And the benefit of beam search is that it's more focused around scoring multi-step reasoning processes. So in this case, you can create multiple different solution paths or beams, and then you can evaluate which of these beams is the most likely to yield the right answer, and then you can create separate subpaths from those beams in order to continue to navigate towards the optimal solution. What's interesting about these different search strategies is that in many cases, it actually allows a much smaller model to compete with models that are much, much larger than them on the same task, because the smaller model is given the opportunity to think for a much longer period of time and explore different possible solutions before ultimately coming to a conclusion. So what do you think? Is the future of AI reasoning more about smart training strategies or efficient inference optimizations, or both? Drop your thoughts in the comment below, and if you like this video or found it helpful, or if you want us to dive into any one of the topics covered in more detail, please feel free to give us a comment, definitely give this video a like, subscribe to our channel, and we'll be back with more.